This is Jim. Today is our last training about AC60 series training. And today I will introduce the CNC control. We can, here we directly start from how to create it in the project. First step, we right click application to add the object. Here we have this CNC program. And when you create it, the CNC program, you can name it and select the implementation and compare mode. These two. For the this is the selection of these two selection. For the compare mode, we have these three modes. And for the implementation faults, we have this DIN, list standards and table. I will introduce this later. And this is when you select this standard, we use G-code to we import G-code and to run the G-code. And the supported G-codes, the G-code supported in our software is according to this standard. For the details, you can search it online. It will show all G-codes supported in this standard. And also, if you select the select to table, you will get this table, and you use how to say, filling the data in this table to get the curve. This is two way for the G-codes running. And after here, after we created the CNC program and click here, click this CNC, double click, you will get this setting. And for this setting is divided into these parts. First part is the display of our curve. And the second part is the adding of our curve. And here we also have upload and import of our G-code file. And then last, here I have another part. We can check the, for example, CNC inform. Here we show the version of the function block, how many lines, how many objects in your code. And you can also here you can check the running position, the relationship between time and position, time and velocity, acceleration and drag for different axes. This is x, and this is y. And here you can use this button to move your curve. Some other setting, for example, here you can select to display the interpolation points or not. Display the grid. And also, this is our oranging curve. And if you add uh, some some codes, for example, this to do some process of your curve, and you can click this button to show the curve after process like this. Here I use this to use this code to smooth the angle part. So you can see after the process, the angle is changed to this circle. It will be more smooth during running. And uh, after you import the G code to software, we need to number the G code. Here, if you didn't number the G code, you will get this error, missing n words at the beginning of the sentence. So here we can CNC. Here we have this button. Renumber CNC program. So it will get the number of each line of your G code. And click on each line, you can see the responding curve in here. For the G codes, you can create it G code by third part software. There will be some software you can import the curve, for example, the XF curve, and it can convert the curve to G code, and you can import G code to software. And also, you can directly import the DXF uh, file to the software, and then the software can help to convert the curve to the G code. I will show it later. Okay, and the next part here, after you created the CNC, you will also get this CNC setting. And now I will introduce the setting of these three parts. First part is this table editor. This table editor is used to select this parameter to display it in this table or not. This table is here when you create it the CNC program. If you select the form of each as table, then you can use this. You can use this CNC setting table editor to display it, to change it like this. Here we can change it to table like this. And in CNC setting, I check this X resolution. And now here we can set the X resolution of each segment. If I didn't check the X resolution, we can't change it. And this setting, pre-interpolation. This setting, first the cycle time. Here for the same curve, I set different cycle time. You can see the smaller the cycle time is, the more points will be the curve will be divided into more points like this. You can see here have many key points to divert the curve to different segments. And also here we have the velocity modes, 5 selection, T-type curve, S-type curve, and so on. And last also we can set the jack limit of the during running. And here I use default setting. Okay, the last part is this pairs preprocess. Here you can see many. Here have many available function block, and for all these function block is used to how to say to preprocess our curve. Take this one as an example. SMC round path. This is used to preprocess the angle. And here you can double click this SMC soft path, and this will change to this active function block instance. And right click, you can set the parameter of this SMC road path. For this setting, for this function block, we have two settings. First is radial, and the second is this angle TOL. And the first, this d radius is the length of this part. And this angle, the angle is in picture is this alpha, the angle of this alpha. And in G code, we use G52 to start the angle loading, and we use G50 to end the angle loading. So you can see here in the project, in this here I start the angles loading, and here I stop the angle loading. And the curve between these two G code, these three parts will be preposed. So you can see these two angle is changed to this circle curve. This is the defined of this parameter. First, for the angle, if the angle is smaller than setting value, here I set this as 40. So it means when the angle of alpha is smaller than 50, then then this curve will not be preprocessed. And if this angle is bigger than 40, it will be preprocessed. And then the distance of this d, will be the smallest value between these three parameters. First parameter is 50% of L1. Second parameter is 50% of L2. And then the third parameter is the sum of d and this parameter. Take an example. For example, L1 is 50, L2 is 60. So here, this will be 25, and this one will be 30. And then this parameter is 20. And what's this D? This D is this parameter in G code. If we set it as D0, then here is 0 at 20. If you set it as, for example, 40, then here will be 40 at 20. So, for example, here I set D0. So this is 20. And the length of D will be smaller value between these three. And the 20 is smaller one. So here, the ratio of uh, this curve will be 20. So this is how we define this angle, this circle. How we define this circle and the conditions about conditions of whether we do this pre-process or not is according to this angle, the value of this angle. Okay, like this. Here I set this D as 10. And when I change the curve, first here, when I change this D value, you can see the ratio of the angle is also changing. So it depends to your requirements. And here, and this point, you can see this alpha. The alpha is smaller than 40. So this angle, we didn't do this pre-process operation. But when it's bigger than 40, we do this pre-process. So this is the usage of this one, SMC smooth path. Oh, sorry, not this one. Here this picture is wrong. It should be this one, SMC road path, not smooth path. And some other function block. For example, this SMC check velocity. This function block will check all key points around the machine path to ensure the parameter, such as jolt velocity, TCP velocity, and some other parameter are safe. And this one must be added to here. And the default is here. This one we can't delete it. It must be in this active function block in existence. And also some other function block, for example, SMC avoid loop. This function block is used to avoid some path loops. It can detect and remove some un-university closed loops. So it can shorten the whole travel distance. And also some other usage of other function block. And you can get the usage of this function block on online. So here we can skip this part and show you how to. It's very easy. Here you can in CNC right click, load program from ASCII file. So you can import the G code. Import the G code to software. like this. But after import, you need to remember the G code. This is CNC file import, and you can also output. First one is write program to ASCII file is used to export, and also here you can import the XF file directly by this import from the XF file. And the system will convert this curve to G code. Okay. So this is import. Our second part, file import. CNC file import and TXF curve import. And the last part, I will introduce some relative function block. This is the some relative function block I used in my demo program, MC Power, and this most important SMC interpolator. This function block is used to run the G code and position reading. Okay, I will introduce the one by one. This tool is very easy. Okay, we can keep these parts. I have introduced it in other training. And this first parameter is execute flag used to start the running. Second parameter is used to bind our CNC program. And this three is three different stop running modes. First one, slow stop. When you trigger this input, the machine will stop according to the deceleration. And the second, emergency stop. When you trigger this flag, the machine will directly stop, but it may have some damage to the machine. And this selection, white and next stop. When you trigger this input, the machine will stop after it's finished the current segment. For example, if you trigger stop when the curve is running in this point, and finally the machine will stop at this position when it finished this segment and stop here. And some other parameter, for example, a speed ratio, speed curve type, interpolation cycle, and a single step running. When you trigger this single step running, it will only run one line G code. And you stop it, run it, set on it again, it will run the next segment one by one. For the output, we have this parameter is the output position of different axes and the working status and the current number of the paths. And these two parameter, these two function block. First one is used to analyze the axis position based on the kinematic model. And the second, second parameter, second function block is used to configuring the size and the position inputs of the kinematic model. It's in here I use it to set the display of our visualization. And this function block is used to control the motion axis according to input position information. And in visualization, I add this SMC virtual gallery to this object. And bind the function block to this TRAFOF gallery to this one. TRAFOF gallery 2. So you can see here we can set the length of X and Y here to set the size of this visualization object. And let's check the program. First to enable our virtual axes X and Y. And this to run the G code. And for the output, we use this output. We set this output to the input of this function block, and this function block will, as I said here, it will analyze the axis position based on output of this function block, and get the X position and the Y position. And we use the real-time X position and the real-time Y position to these two function block to control our X and control our Y axis. And finally, use this function block to display it in our visualization. The demo is very simple. You can check. Hey. Oh, here. Here we run this function block. And check in visualization. Now it's in this position to draw this circle. And stop and lead here. You can run it again. From start position to here. And run this. And this. You can see in this position, it's a circle, not line, circle, because we set it. We do this angles move by G52. This is the curve we are running now. Okay. So this is our today's training, and I will send you demo. You can input and also send you uh, some DXF file and some G code file. You can input other picture and other curve to run it, and our today's training is finished.